Electricity is everywhere. It's in all of the daily appliances we use. The simple example, the light bulb, which uses electricity and converts it into light energy. The next example, the microwave and the oven, which use electrical energy and convert it into heat, which we can use for our cooking. Any display that you might have used likely relies on electricity, like your TV, your laptop, your mobile phone. All of them convert electrical energy into light energy, and also some heat is generated in the process. It's common to say things like it runs on electricity for appliances, but I want to focus on this video to explain that electricity is not like a fuel, like a gas or a petrol. It doesn't get used up similar to them. I want to explain electricity in terms of the flow of electrons throughout a wire. In this video, we'll look at electrons, we'll look at metallic lattices, and we'll look at the physical quantities associated with electricity, some of which we'll cover in this video and some in the next one. So, to begin, let's start out with electrons and metallic lattices, the basic principles. We all know that atoms have a nucleus at their center, which is positively charged, and have surrounding electrons which are negatively charged. These negatively charged electrons are what are responsible for the conduction of electricity. How, you may ask? Well, for that, let me introduce you to metallic lattices. This explains how atoms in a metal are arranged. You see, metallic atoms are not like other materials. In metals, the electrons are not bounded to the nuclei. And this means that the electrons are free to move around. Now, the electrons don't have a precise location. The location is uncertain because of quantum mechanics. However, here we'll show an exact location to make it easier and for the sake of demonstration. Because these electrons are free to move about, there exists electricity. Now, you might be wondering, if they're not bounded to each other, how do the nucleus and electrons stick together? And the answer is that there exists a strong bond between the nucleus of the atom and the electron, even though they're not bounded. This is because of the electrostatic force of attraction. Now, the electrostatic force is part of the electromagnetic force, and the electromagnetic force is considered a strong force. The reason this exists is because nuclei are positively charged and electrons are negatively charged. So now we know how electricity works. Electricity is the flow of free, mobile, or unbounded electrons, or a sea of electrons, and this theory used to explain current is called the electron current theory, because current is the flow of charge, and this theory says that electrons are responsible for this flow of charge. But before 1897, things were a bit different. You see, in 1897, the electron was discovered. And before the discovery of the electron, physicists believed that the proton and positively charged particles were responsible for the flow of electricity. Now let's talk about some physical quantities associated with electricity. The first one being charge. Now, charge is the measure of electric content. It's a measure of how many charge carriers you have. Charge carriers include particles like the proton, electron, quarks, any particle which has a charge. There are many more charged particles other than these. The unit of charge is the coulomb, denoted by C, which was named after this scientist, Charles Augustin D. Coulomb. Now, this method doesn't actually fully explain electricity, and I'm going to show you through an example. Consider you have a box with 6 coulombs of charge. This charge could consist of any number of protons, any number of quarks, and any number of iron ions. It could use any particle which has a positive charge, and you could get 6 coulombs from that. However, here we have a problem. We're defining charge based on charge carriers, and each charge carrier has its own charge. So what really is charge? Well, charge is an intrinsic property of a particle similar to mass, which just exists It cannot be simplified further. In fact, if you look at the Wikipedia definition for charge, you'll see that it defines charge in terms of the electromagnetic field and how particles having a charge experience a force in that field. And it describes charge based on its effects rather than what it actually is. Another quantity we're going to look at is current. Current has the symbol I because scientists are too bad at naming things, I suppose, and it gets this word from a French word which means current intensity. Now, current is the rate of flow of charge, and some people like writing change in time instead of time, but I prefer simply to write time. Calculus students can use this notation. Let's consider a graph of charge against time. This means that we have a current of 1 second, 1 Newton, 1 kilometer. Oh, sorry, the unit of current is the ampere. 1 ampere simply means a current of 1 coulomb per second. And let me explain what that means. Consider you have a wire with a lot of charge conductors or charge carriers like electrons flowing, and you measure how many electrons are flowing past a point per unit time. The charge flowing per second, this is the current, and it's measured using something called an ammeter, which is a device which measures how much charge flows across it, or if you want to say how much charge flows through it. We can also calculate the current based on the number of electrons. Simply multiply this number by 1.6 times 10 to the minus 19, and this number is known as the electron charge. It's a constant which tells us how much charge each electron has. So if you multiply the number of electrons by the charge of each electron, you get the total charge present. Now you divide this total charge present by the time, and this gives you the current. Or in short, it gives you I, which is the symbol for current. Thank you very much for watching. I hope you learned something from this video and you gained some knowledge. If you did, and if you like this video, please give it a like. It really helps this content reach other people. And if you want to see more videos like this, please do consider subscribing. It really helps to support the channel. Thank you very much for watching. I hope you have an excellent day.